Welcome back to my channel Maths Made Easy with AB. So we are continuing our series of functions. So we have already studied about basic functions, understanding of functions, what are functions and all. So functions defined by y is equal to f of x. So we have seen various graphs. If you have not seen my series Play with Graph, I'll highly recommend you to go through the series first and then get into this entire series of functions and calculus. So eventually today what we will do is we will study about domain. So domain is an important part. Domain and range actually is an important chapter when it comes to calculus. So today will be the first lecture on domain. Maybe we won't be able to complete domain in this lecture today. So we will be having another video on domain, the next video. If you have not watched my earlier video, I'll recommend you to watch those and then get back to the domain part. So now let's understand what is domain of a function. So what is domain? Actually, say for example, you have got a function y is equal to fx. So what are the values of x? What are the acceptable or the permissible values of x for which you get an output of y? So which means, say for example, y is equal to fx. So in simple layman language, in layman term, if I try to explain you, so I had given you the example of weighing machine in the first lecture of this calculus, this function chapter. So when you get a weighing machine, so say for example, the weight limit of this weighing machine is 150 kg, which means it can record weight up to 150 kg. So somebody of weight 75 kg comes in and stands on this weighing machine. So this is the weighing machine. Yeah, this is a weighing machine. Someone of 75 kilo comes and stands on this. So what output will the machine give? The machine will show 75. So which means you are entering the value of x is equal to 75 and the value of y you are getting was 75. Somebody of 150 kg comes and stands on this machine, the output that you will get is 150 kg. Now say for example, somebody weighing 210 kg comes and stands on this machine. This machine, will it show any value? No, it won't show any value. This machine won't work, which means 210 kilo is not an acceptable value for this machine. 210 kilo is not an acceptable value for this machine. This also means that 210 is not a permissible value of x, and hence this cannot be the domain for this function, that is the weighing machine. So basically domain is the acceptable values of x for which you will get values of y, for which the function is defined, right? Which means the acceptable values of x for which the function is defined. So this is the simple way in which you can understand domain. I think students, this was clear to you all. Let me now make you understand. I'll always draw a graph and show it to you for your understanding. Say for example, somebody has given you y is equal to mod x. So, and this is fx, say for example. So how does this function look like? So this function looks like this. In Play with Graph series, we have already seen how to draw graphs. So I'll simply draw it over here, right? So this is y is equal to mod x. Now, what are the acceptable values of x for which you will get values of y? All values of x. You can see all values of x. Put any value of x, you will get a value of y. Put any value of x, you will get value of y. Any value of x, you will get value of y. Which means here x can be real, right? X can take real numbers. X can be any number, right? On the x-axis you can see. Which means that the domain of this function y is equal to mod x is real number. X belonging to real numbers, or any real number is acceptable in this case. I think this one was very much clear to you all, right? Say for example, domain of, say somebody asks you find the domain of sin x. So for the domain of sin x will also be what? R, real number. Any number you can put over there. What will be the range? We will see in the range chapter. Here the range will lie from what? Range is basically what, by putting the permissible values of x, what is the value of y that you are getting. I'm just giving a description. I will not deep dive into range in this chapter, in this video. So basically, what are the values of y that you are getting? Simply by this graph, you can see the range is x belongs to r. This is the domain. What is the range of the function? Range of the function means y belongs to how much? 0 till infinity. 0 included, because at x is equal to 0, you get y as 0. So this is the domain. Domain means from where to where the values of y lies. So the y lies only in the positive side because this is a modulus function. So the domain is y belonging to 0 to infinity. This is a very simple concept. If you know the graph, you can do anything. I'll give you another example of domain and range. I'll give you another example of domain and range. Say for example, somebody is asking you the domain and range of sine x. Y is equal to sine x. So you know the graph of y is equal to sine x if you have seen my video on play with graph. So this is +1, this is -1. Sine x lies somewhat like this, and this continues and this continues. This is pi by 2, this is pi, and also on and so forth. So you all know this graph, right? So I think this is clear to you all. So accordingly it goes in 2 pi and so on so forth. So this hump is of pi, right? Now you see x is taking any value. X can be this. This will give you this part will give you this value. Over here x will give you this value. Over here x will give you this value. So any real value. So x belongs to what? Real number. Any real number can be the x can take, right? So this is the domain. What is the range of the function, students? What is the range? Permissible value of y. So what is the value of y that this function is attaining? So y lies in between +1 -1. So y lies in between what, students? -1 till 1. So this is the range of this function. Simply from the graph we can predict. So x can be real, which means for any values of x, this function will be what, students? This function will give you, this function can be defined, and range is for what? These values of x, where is the function lying? The function is lying in between 1 and -1. I think this was clear to you all. Let me now standardize or show you some of the important methods by which you can actually solve problems. So first you have to understand that rules for finding domain. So I'll just write the rules for finding domain. So number 1. So these are some of the rules that you will have to remember while you are finding domain. Yeah. So expression, the first point is the expression under even root is always greater than equal to 0. Expression under even root is always greater than equal to 0. Right, students? Understood? Which means which can be square root, fourth root, sixth root, whatever. Yeah. So that is one thing. Second part. So this is first thing which you will have to remember. Expression under even root. For example, somebody has given root over x square plus x minus 1. So what is the domain? So this part, students, this part has to be greater than, this part has to be greater than equal to 0. You know that this cannot be negative because it is square root. It will give you complex numbers. So basically that is how it has been defined. Expression under even root, the square root should be greater than equal to 0. So this part, x square plus x plus 1, to find the values of x square plus x minus 1, this part has to be greater than equal to 0 for this function to be defined. So this is the first rule which you have to ascertain. I'll show you some problems of how to solve this. First, let us write the rules, understand the rules of finding domain. Second is denominator. Denominator cannot be equal to 0. Very simple, students. 1 by x, y is equal to 1 by x. This part, if it is 0, this function will not be defined. So basically denominator of any function shouldn't be equal to 0. The denominator part shouldn't be equal to 0. So if the function is y is equal to log x base a, if the function is log x base a, you will have to remember that this x should be greater than 0. This a should be greater than 0. A cannot be equal to 1. A cannot be equal to 1. A has to be greater than 0. So if a is 1, what the issue will be? Log x by log a. You can write it this way. If this becomes 1, students, log 1 is 0. Log 1 is 0. So this part will again become like this. So denominator not equal to 0. Hence, a cannot be equal to 1. Just I taught you the logic why this is. Else you can remember this. So basically, x has to be greater than 0. A has to be greater than 0. But a cannot take the value of 1. All other values greater than 0 it can take. So I think this one point was very clear to you all. Right, students? Say for example, you have a function y is equal to fx. Students, you have a function y is equal to fx whose domain is d1. You have another function, students, y is equal to gx whose domain is d2, right? You have a function y is equal to fx whose domain is d1. You have another function y is equal to gx whose domain is t2. Then the domain of the function fx plus minus gx will be d1 intersection d2. So basically, if d1 has three numbers 1, 2, 3, if d1 has numbers 1, 2, 3 and d2 has number 2, 3, then the domain will be 2 and 3, right, students? Or say d2 is 2 only, so the function, or 2 and 5. So what is the intersection, students? Only 2. So 2 will be the domain of the fx plus gx if I am adding two functions. What will be the domain of fx into gx, students? It will again be same, d1 intersection d2. Very logical this is, but only for writing sense I am writing it to you all so that you can remember, right, students? So what will happen? What will happen in case of fx upon gx, students? This will be what? d1 intersection d2. This is true. Minus gx, this denominator part, minus gx is equal to 0. So this cannot be equal to 0, right? So we are removing that part, gx is equal to 0. So fx plus minus gx will be d1 intersection d2. Multiplication will also be d1 intersection d2. But division part, d1 intersection d2 will be there. But you have to remove this part equal to 0, right? Students, I think so these are the four principles which you will have to keep in mind. Just these four principles you have to keep in mind in order to find domain of a function. Yeah. So let's now see some examples of how to find domain. Let us see some examples of how to find domain. Say for example, somebody has given you the question that find the domain of fx is equal to root over x square minus 5x plus 6. Very quickly I will solve this problem. I have already taught you wavy curve method in one of my videos. If you have not seen my lecture, students, earlier videos, I will highly recommend you that you see all of the videos that I have published till now, so that you can become very much clear in mathematics. And I am following a similar way so that if any part comes in, that has already been covered beforehand, right? So wavy curve video part 1 and part 2 you can see in order to solve these problems going ahead. So the question, students, is find the domain of the function fx is equal to x square minus 5x plus 6. Already told you to find the function, so this part has to be greater than equal to 0. This part has to be greater than equal to 0. This can be 0, yeah, right? So root over 0 is 0, so that is defined. So x square minus 5x plus 6 is greater than equal to 0. So this will give you x minus 2 into x minus 3 greater than equal to 0. Right, students? I think this is very much clear. Now I will apply wavy curve here, students. Already taught you beforehand. So what are the critical points? You have to equate this to 0. I am repeating, but I am giving you the link in the description of wavy curve video. Do see that video, then try solving this problem. Else you will be in trouble when this problem complicates. Yeah. So now, students, I always start from this side. I have drawn this on number line. Now since the power is odd for both, so we move downward. Again power is odd, so we move upward. So plus minus plus. Right, students? So this is how we draw wavy curve. Greater than equal to 0, students. So greater than equal to 0 means you will have to take the positive part. So x belongs to minus infinity till 2 included, because there is greater than equal to union 3 till infinity. Union 3 till infinity. So this is basically the domain of the function fx is equal to root over x square minus 5x plus 6. I think this is how much simple it is to find the domain of a function. Right, students? Let us now take a second example to find the domain of a function. Let us see the second problem. Let us take a bit difficult. So fx is equal to root over x square minus 3x plus 2, x square minus 3x plus 2 plus 1 upon root over x square minus 3x minus 4. So this is the question, students. Understand this as fx plus gx. So basically you will have to find, this is fx, and students, this function is gx. We are adding two functions, right? If it has a domain of d1, it has a domain of d2, the ultimate domain will be d1 intersection d2. Just we saw this earlier. So now let's get started with this, trying to solve both the problems, both the part. So here you will see this part, x square minus 3x plus 2 should be greater than equal to 0, right students? As simple as that. What will happen here? Now this is in the denominator part, students. So x square minus 3x minus 4 will be greater than 0. It cannot be equal to 0. Just few minutes back I told you that denominator part, it should have been like this because it is in square root form, yeah, even root form. But it cannot be equal. Why? Because it is in the denominator. Because we also know that by the second logic, the denominator cannot be equal to 0 because it will become 1 by 0 form, right? Now simply let's solve this. So this is x square minus 2x minus x plus 2 greater than equal to 0. If I take x common, x minus 2 minus 1, right, greater than equal to 0. So x minus 1 into x minus 2 greater than equal to 0. X minus 1 into x minus 2 greater than equal to 0. I think this is clear to you all. Yeah. So now if I solve this part, so this will basically be x minus 3. So let me just solve it for you all. X square, right? X square minus 4x plus x minus 4 greater than 0. So x common, x minus 4 plus 1 greater than 0. So x plus 1 into x minus 4 greater than 0. X plus 1 into x minus 4 is greater than equal to 0. So 4 and minus 1 are the two critical points. Quickly I'll do what? I'll write these two. So basically this is giving you x minus 1 into x minus 2 greater than equal to 0, right? Students, this is the part that you got from this one, and here you are getting x plus 1 into x minus 4 greater than 0. I taught you the solution, so I am just removing this part. This part is not needed anymore. So this is the part you got, right? I made it cleaner. So this is the part that you got. Now students, understand wavy curve here. So this is 1, this is 2, and simply I draw the wavy curve plus minus plus. Right students? Plus minus plus. So here x belongs to minus infinity till 1 included, union 2 till infinity. Very much clear? If I solve this, so one is 4 and another is minus 1, and again the same, so plus minus plus. So here x belongs to minus infinity till minus 1, not included because this is only greater than sign, not equal to, union 4 and 4 comma infinity. I think this is clear to you all till here. Now you will have to take the intersection of both of this. So this is very simple. Draw the number line, plot this first. So you have what? You have 1, right? You have 2. So this is 1 is included and this is the form till here. 2 is included and till infinity it goes. So this is the form, right students? So this is clear to you all. Now minus infinity till minus 1. So minus 1 will be somewhere here. So basically not included, and this is the form. Not included and this is the form, right? And then it is 4 till infinity. So 4 till infinity not included. So 4 is not included means here till infinity. Right students? So which is the intersection part? So this part has intersection here. This part has intersection here. So what will be the final domain? X belongs to minus infinity till minus 1, not included students, union 4 till infinity, 4 and infinity not included. So this will become the final domain of the function, students. I think this is clear to you all till here. If it's not clear, just see how I have used initially wavy curve method, This is wavy curve method. And then by simple logical nomenclature, I have found out the domain of the function, right? So domain of the function is x lying in between minus infinity till minus 1, right? Minus infinity minus 1 is not included. Minus 1 is not included. Here 1 was included, 2 was included, but here it was not included because the sign was greater than, and till from 4 till infinity will be the thing, right? The blank here means not included and the dot means the value is included. I think students, this question was very clear to you all. Let us take another example. Let us take another example to make your concepts very clear, your concepts crystal clear. Yeah. So students, I hope you are liking this video. If you are liking this video, don't forget to subscribe to the channel. It will help us grow mutually. And do circulate this circle in your circulate this video in your circle so that your friends can also enjoy if they're facing any difficulty. Yeah. So now fx is equal to, say for example, I get the question 1 by root mod x minus x. Very important question. Earlier IIT had asked this question. Find the domain of this function. Fx is equal to 1 by root over mod x minus x, students. So this is the question. So now it is very clear that mod x minus x should be greater than 0. Anything under the square root should be greater than or equal to 0, but since it is in the denominator, it will only be greater than 0. So basically mod x is greater than x. You have to solve this, students. Mod x greater than x. In equation solving, I have told you, you will have to draw the graph of this, you will have to draw the graph of this. So basically y is equal to mod x, graph is here. This is x axis, this is y axis. Right, students? Right? This is the graph of y is equal to mod x. And what is the graph of y is equal to x, students? So this is the graph of y. So this is repeated. I'm just drawing it over this. This is the graph of y is equal to x. Right, students? This is the graph of y is equal to x. And this is the graph of y is equal to mod x, this black one. Where is the graph of y is equal to mod x greater than y is equal to x, students? So basically, if you see this part y is equal to x, mod x is giving greater value than y is equal to mod x, because y is equal to mod x have moved downwards, it is giving negative value, whereas this is giving you positive and more value than y is equal to x, students, right? So what will be the answer? Will 0 be included? No, 0 won't be included because the sign is not like this. So here the domain is x belongs to minus infinity till 0, 0 not included. Minus infinity till 0, 0 not included is the domain of this function. Fx is equal to 1 by mod x minus x. Right, students? I think this question was clear to you all. Meanwhile, I'll stop the video over here and give you a task for solving. So I've already taught you greatest integer function. If you have not seen the video, do see and understand what greatest integer, least integer, signum function is, and then you can come back and solve this problem. So the question is fx is equal to greatest integer function x minus x, but this is the greatest integer function that you can see in this bracket. You have to find the domain of this function and do use the comment section to comment what is the answer that you are getting. In the next video, we will try and solve out this question. So guys, if you like my video, do subscribe to my channel. Thank you for your time. We'll meet in the next video.